This is a developer I've known for a long time. I gave him a call Wednesday night, this last Wednesday night. And I said, we got something really secret we're working on, and I can't tell you what it is. But I want you to put all your source code on a hard disk and fly out here, and let's see what we can do. And it was nip and tuck there for a few minutes, but they trusted us enough to do that. And that company was Wolfram Research, and that app was not a small app. That app was Mathematica. And it is my pleasure right now to introduce Theo Gray, the co-founder of Wolfram Research, to tell us what happened in the last 5 days. Theo, welcome.
I get the most ridiculous phone calls from Apple sometimes. I mean, this was like 9 o'clock at night, and he's calling. He said, "Oh, I have this great thing, and it's great, and could you port Mathematica? And, you know, I can't tell you what it is, but could you come out and show people on Monday?" So, I mean, you have to understand. So Mathematica has inside it probably the world's largest collection of algorithms. It supports all kinds of programming styles, data formats of all sorts. It's built with, you know, millions of lines of C code. We've got Java code. We've got, you know, the most modern C++ template stuffy widget things, and, you know, we've got ancient code that hasn't been changed since like the Reagan administration, some of which I might have written. This is not a little toy app. This is a beast. Lots of port. But, you know, not to worry, because he said, well, there's this little checkbox, and you click the little checkbox, and you'll be fine, you know, it'll be great. So I said, oh, OK. I'll send out, you know, our crack team of emergency Macintosh developers that we keep on standby. That would be Rob. You know, we'll see what he can do. So we put him on a plane. You know, he gets there Thursday afternoon. Of course, I can't actually tell him why he's going, but he showed up, and they showed him the checkbox, and he clicked the little checkbox, and 2 hours later, he had a copy of Mathematica running on Intel. 2 hours. So for those of you that have been through a Carbon port, OS 10 kind of port, this is nothing like that. I mean, we're talking about 20 lines of source code out of millions from a dead cold start, where he doesn't even know why he's showing up at Apple, in 2 hours to have a working version. Let's take a look. Actually, so I mean, I should say in fairness that there is an awful lot of software engineering built into Mathematica to make this kind of thing possible. There's Rob. There's help from Apple. You know, your mileage may vary, but from where I stand, you know, it's pretty good when, like, your biggest problem with a port is figuring out what to do with the rest of the weekend. So let's take a look here. Now, of course, the most amazing thing is just that it comes up, you know, at launch. Now, Mathematica and the Macintosh are used by people at the forefront of their fields. You know, people who want to push the limits and do things that haven't been done before, like that, for example. Just go back. Those 2 lines there, you haven't seen that before. And in the spirit of pushing the limits, we thought that rather than do something boring, you know, like port a working version that we knew was stable, we thought we'd go ahead and port the current internal development version of Mathematica, which is full of all kinds of, you know, exciting new technologies that actually I can't show you. But I can show you a couple of the interactive things we've been working on. So, oh, that's nice, you know, and now we know OpenGL works. But let me show you something that you probably haven't seen. Now, in the past, you would do typically sort of one calculation. You do one algebraic manipulation at a time, or expansion here. So what we're doing here instead is we're exploring a computational space. We have a tool where we can manipulate and navigate through a world of computation. This is a quick little example. You know, it's simple, it's kind of fun. But it's actually based on a lot of very deep technology that we've been working on for many years to make that possible. We like to do sort of deep technology at Wolfram Research. We also like to do interesting science, hence the research. So this next example, this is something based on Stephen Wolfram's new kind of science notion of exploring a universe of possible simple programs. And And as you can see, this is a very simple program. That source code up there, that's the entire source code in the Mathematica symbolic language to implement that example, as well as specify the user interface that we would like to have to explore this particular computational universe. This happens to be sort of an experimental architecture kind of idea, something you might see built in Las Vegas maybe. But it could just as well be looking at candidate nanotech structures, something like that. So we expect to be seeing a lot of sort of technological applications coming out of the use of Mathematica to explore interesting computational spaces. OK, thanks for the demo, Rob. I'd like to So I'd like to thank Steve for inviting us out to once again sort of push the limits together with Apple. We certainly hope that we will have a universal binary shipping once there's machines out there to ship it to. And I'd particularly like to thank the Apple engineering team for freeing up my weekend. Thank you very much. Whew.